Welcome to the examples video for solving trig equations, where we go over key examples and past paper questions. In the last video, the concept video for solving trig equations, we had to look at where the cast diagram comes from, how we can use it to get two positive or negative solutions, if there is always only two solutions, and why we care about solving trig equations at all. And now we'll go on to have a look at the examples. Let's have a look at some past paper questions. So let's first of all just rewrite what we've got here, so hopefully you can see it a little bit clearer. We've got 7 sin x plus 2 equals 3. And let's rearrange this in a form where we've got sign on one side and just numbers on the other. So we'll start off by taking 2 across the other side. So we'll take away 2 from both sides. So that'll leave us with 7 sin x equals 1. And then we'll divide by 7 on both sides just to get sin x on its own. So sin x is equal to 1/7. Okay, we'll do a quick sketch just so we know what answer we're looking for. You don't have to draw the graphs because you can just use the cast diagram, but it's good to always check that your answer makes sense and correspond with the graph. Okay, so we've got sin x equals a 7th, which is quite low down, so maybe be roughly here, and maybe roughly here, y against x. Okay, so let's get a cast diagram, and we can see that for the graph, our first answer is before 90, because 90 is here. So yep, it's in the first quadrant, and for positive answer, the first answer will always be in the first quadrant, and yep, the second answer is just after 90, but before 180. So we can see the second answer is indeed in the second quadrant. And for positive answers, it will always be in the all section, and then in the corresponding section, sign for sign, cos for cos, etc. Okay, so our first answer would just be from taking the inverse sine of a 7th here. You put that in our calculator, it comes out to be 8.2 degrees, and yet that means it's right at, that's the first answer, and it's right after 0 degrees. And to get the second answer, we just take 180, we take the answer we got away from 180, and then here we get 171.8 degrees. And yeah, that corresponds just before 180. So that makes sense. So then, just to make it clear what our two answers are, we're writing it again. And we just confirm that they do make sense to the graph, so it's likely that this is the answer. Here we are. Right, next question. A little bit different than your usual type of question. And you can see it was worth less marks than a solving trig equation. And it's not asking us to solve a trig equation, it's asking us to write out these three things here in order of size. And this would be a non-calc question, because obviously if it's calc, you could pop it on a calculator and you'd figure it out. What we'd notice first is that it's in terms of size, so the sign doesn't matter if it's positive or negative, it's just how big the number is. So let's get, we don't have to start when in doubt, sketch it out. So quick cos sketch here. I'm not the best at drawing cos, but that'll do. And remember the key points of the cos graph is it is 0 at 90, midpoint's 180, across again 270, and obviously it ends at 360. Okay, so we know straight away that cos 90 is one of the answers, and cos 90 is 0. Oh, didn't mean to drop that out. Cos 90 is 0, so we'll write it down straight away. Cos 90 is 0, so that's going to be the smallest one, regardless, unless there's another 0. Right, let's have a look at cos 100. So cos 100 will be just after this, so cos 100 might be roughly there. Okay, and where's cos? The next one's cos 300. Cos 300 will be roughly here. Okay, so let's go down and find it. So cos 100 will be roughly this answer here. Oh, wrote out by accident. Roughly this answer here, and cos 300 will be way up here. Okay, so the first thing we should notice is that this answer, this 100 here, is only 10 degrees away from 0. Whereas this 300 is 30 degrees away from 0. So because 300 is further away from 0, it's had a longer time to get to a bigger value that the 100 has here. So we're going to say that the cos of 300, we don't know what it is, but we just know that it's bigger than cos of 100. And we know that they're both bigger than cos of 0. So actually the order they're written in is already the order of size. And that just means that cos 100 is bigger than 90, cos 300 is bigger than 100, and that's us sorted. Okay, this is a notorious windmill question that we've seen appear in two concept videos so far. Now we're actually the question, so I'll zoom out a little bit just so you can see the question. And we've got a turbine here, and this blade A, and apparently the height of this blade can be measured, can be modelled using this equation here, where x is the angle from the vertical position, so if we go round the rotation, x would be this angle here. Okay, so the first question is asking us to calculate the height after it turns through the angle of 60. So it's only worth 1 mark, so it should be just a simple substitution. And we'll see that it is. So I'll get right out the equation again. And it's asking us what's the height after it's turned through an angle of 60. So let's replace x with 60 degrees. And if you pop that in your calculator, because it will be a calculator question, cos of 60, I'll write the side here, cos of 60 is just a half. So we sub that in, we get the height is 40 plus 23 times a half. And you pop that on your calculator, you shouldn't have to pop it in your calculator, but if you do, it'll come out to be 103 over 2 if you want to do it in a fraction. Or if you write it in terms of decimals, that's 51.5, but it's in meters. It said at the start here, it's in meters, so we'll leave it in meters. Okay, find the height of the tip of the blade A. Sorry, find the minimum height of the tip of the blade A above the ground. Okay, so when is this going to be at its smallest? Well, we remember that cos is at its smallest when it's at 180 and it's equal to minus 1. So this whole thing will be smallest when cos is equal to minus 1. So we'll sub in cos equals minus 1, so we'll get the height equals 40 plus 23 times cos of x, and we're replacing cos of x with minus 1, because that's when it's at its smallest. And if we do that, that gives 40 minus 23, and then, so the minimum height, is just 17 meters. Oops, 17 meters. There we are, and this is the standard solving trig equation here. You can see it's worth 4 marks. Calculate the values of x, for which the tip of the blade is 61 meters above the ground. So I'll just copy the equation again. And it's asking us to find x when the height is 61 meters above the ground. So we'll just replace h with 61. And we'll rearrange to get our usual trig equation. So I'll take 40 across the other side. Actually, I'll rewrite this first just so the cos x is on the left, because it's a bit nicer to solve when you think about what to solve for is on the left. You don't have to do this. I just think it'll be easier to see. So I've just flipped the equation about, and that's fine. Right, I'm going to take the 40 across by minusing 40 from both sides. So that leaves us 23 cos x on the left and 21 on the right. And then to get cos x on its own, we just divide by 23, so we end up with cos x equals 21 over 23. And we want two answers. And it says calculate values, so it's plural. And we can see from the graph that it'll probably, for an arbitrary height, it'll reach at 2 points. So let's get our cast diagram out to take our 2 quadrants that we need. I won't sketch it this time. Cast diagram. And the first, because it's positive, the first answer will be in the all section, and the second one will be in the cos section. And you can see actually from the graph here that, in fact, the first one will be in the positive quadrant here. This will be 0 to 90 here. And the last one will be in the last quadrant, actually. So it does check out, but the cast diagram is much easier to use here, so just look at the cast diagram. So the first answer we get just from doing the inverse cos of the angle, so I'll do that here. And the inverse cos is 21 over 23. Pop that in your calculator, it comes out to be, pop it in our calculator, 24.1 degrees. And what I'll do actually is I'll just move this one down and give us, gives a little bit more room to work with. So let's drag it down. And the second answer, we just do 360 minus our first answer, and pop that in the calculator just to make sure you don't make any small arithmetic mistakes. And that comes out to be, if I pop it in the calculator, 335.9 degrees. And we'll just write out both our answers to make it explicitly clear which ones, what answers are. And you could just box the answers after you've done the working, but I like to write them out just to make it clear exactly what we're saying. So we're saying that it's 61 meters off the ground when it's at these two angles. Sorted. Let's go on to the next one. This time we're still on a tan equation. And it's standard equation, worth 3 marks. So let's get going. So we've got 2 tan x is equal to plus 5 is equal to minus 4. Let's rearrange to get tan x on its own. So let's take the 5 across first. So to get rid of this 5, we need to take it away. So we end up on the right hand side with minus 4 minus 5, which will be a total of minus 9. And then to get tan on its own, we just divide both sides by 2. So we end up with tan x equals minus 9 over 2. Hold on, that's smaller than minus 1, so usually there's no solutions for that. But for tan, there's always 2 solutions. If this was cos or sine, you would just say there's no solutions because they don't have solutions out with 1 and minus 1. But tan always has 2 solutions because it goes off to infinity in both directions. So, cast diagram it again. And we notice that it's a negative answer. So instead of ticking A and C, we tick the other 2 instead. We tick C and S. But we still need to get our first answer, to get our first positive answer to get the 2 negative ones. So to get the angle we're going to use to get the other solutions, we just take the inverse tan of what we've got there. Inverse tan of positive 9 over 2. Remember, whenever you find the inverse of numbers, you always use the positive value. If it's a negative question, you just then use the other 2 quadrants. Okay, so pop that in a calculator. Inverse tan of 9/2, you get out 77.5 degrees. And remember, we need to use this to get the other two answers. So we'll do the cos one first. So we'll do 360 minus this. 360 minus 77.5. That looks like a 2. Let me just rewrite that. 77.5. Is popping the calculator, it comes out to be 282.5. Again, you can do this in your head, but you might as well use your calculator. It's a calculator question, just to make sure. And then another one will be 180 minus the answer we got, and that will come out to be 102.5. And this time I'll just box 2. I don't want to write them out again, but there's just two answers here. We'll make it clear that these are our solutions. And we'll do one quick other example, stuff covered from the concept video, and we'll have a look at how many solutions these two guys here have. So remember, the regular sign just always has two solutions if it's between -1 and 1, and 5/7 is between -1 and 1. So this here will have two solutions. And cos the same if it's between -1 and 1, and -0.7 is between -1 and 1. So this will have two solutions always for this value. And the key thing to remember is that sine and cos usually have two solutions. I've never seen a past paper question where it's not two solutions. But technically, if it is equal to something like 2, then there'll be no solutions. Or if it's equal to 1 or -1 exactly, there won't be one solution. And tan just always has two solutions. Okay, we'll leave it there. That's all. We'll look at some past paper questions, kind of look at the examples that might come up. And we've also recapped the number of solutions thing from the concept video that we did. Perfect. I hope you enjoyed, and double check, go back and have a look at the concept video if you want to have a little bit more look at more detail where the cast diagram came from.